Okay. Uh, Questions a student had on a homework assignment. We had the expression backward apostrophe a x squared. And I'm just going to call that variable a x squared plus variable b x cubed here, plus variable b x squared plus variable c x plus variable d, where a is 4, b is 6, c is 9. Well, then what does this mean for these values of a, b, and c? It means backward apostrophe a stands for the number, so it'd be 4x squared, x cubed, plus 6x squared, plus 9x. And then d in our scheme is a plus b. And I believe everybody understands that, so that's easy to find. Okay, so, and what is this? This is a polynomial of degree 3. Now there's the expression, same expression we have here, but then over x cubed. What does this mean? Well, it means 4x cubed plus 6x squared plus 9x plus 10 divided by x cubed. And you're asked to show that this is equal to, well, I believe it's stated a plus b over x plus c over x squared plus d over x cubed. This means 4 plus 6 over x plus 9 over x squared plus 10 over x cubed. Okay, now the question is, what's the algebra that connects this to this? I'll just say, what are the algebra steps? From here to here. What's the basic? It's fundamentally algebra 1 or very early algebra 2 connects this to this. So to the student, I would say, if you don't understand how to get from here to here, tell me you don't understand how to get from here to here. But it's very clear application of the distributive law and the laws of exponents. So I'll just say, I'll say rules for exponents. Now I'll say on the assignment, because this is really kind of focused on the student, but everybody can kind of take a lesson from this. In the work that I got an expression like this that was to be somehow related to this. And my question was, what was your line of thinking that got you from here to here? because this doesn't appear to be related to this in any significant way, except that some of the numbers are the same. And of course, this expression then would be what? 4 minus 6 up here, and x plus 9 here, and x squared minus 10, and x cubed here. But this is in no way equal to this. When you plug the numbers in, the expression you get here is not in any way equal to this. So I'm going to tell you how this expression simplifies, just to make sure we understand. Okay, this is going to be 4 minus 6 divided by x plus 9. And that's divided by x squared minus 10 divided by x cubed. Well, this means, first of all, 4 minus 6 is negative 2. So I'll replace this with this. And this division here means divided by x squared minus 10 over x cubed. But that's equal to negative 2 over x plus 9 multiplied by the reciprocal here, which is x cubed over x squared minus 10. So that's minus 2x cubed. If I multiply x plus 9 by x squared minus 10, well, x plus 9 times x squared minus 10 is x times x squared minus 10 plus 9 times x squared minus 10. If you do that by the distributive law, then x times x squared minus 10 gives you x cubed. X times negative 10 gives you negative 10x. And I'll put that over here, leaving me a space here, because I know when I do 9 times x squared, I'm going to get plus 9x squared. And then minus 90. So this equals this. If A, B, and C have these values, and this seems to be completely unrelated to this or to this. Okay, well, those are my questions. Now, coming back to this expression. And hopefully this is legible, because right now I'm saying everything is pretty well out of focus. And, that's my camera. So hopefully everything before was in focus. In any case, this is what we have. Now we want to evaluate this expression, and this would be, okay, this was said to be P of X. So let's maybe label that, and we'll come back. So we'll just say this is what we call P of X. And it's equal to this. So this expression is P of X over X cubed. This expression here is what we want to do is evaluate, and let's see, how am I going to do this? I think I'll do it like so, and we can come over this far. I can handle that. So evaluate P of X over X cubed for X equals 10. And I haven't quite given myself enough room here. I can't write up real high on the board today. I injured the shoulder a little bit. Take a few days to recover. Okay, so evaluate P of X over X cubed for X equals 10. Now we could do that. We could plug 10 in for all these values of X, then evaluate P of 10, and then we could cube 10 to give us 1,000. And we could then do the division, but it's easier to do and most relevant form for what's coming is the 4, 4 plus 6 over X plus 9 over X squared plus 10 over X cubed. And I want to put P of X there, so I'll just punctuate it like this. This is going to P of X over X cubed equals this. So P of 10 over 10 cubed is 4 plus 6 over 10 plus 9 over 10 squared plus 10 over 10 cubed. And we don't need a calculator to do this. We don't need any fancy computer algebra system. This is 4 plus 6 over 10 is 0.6. 9 over 10 squared, 10 squared is 100. 9 over 100 is 0.09. And 10 over 10 cubed is 10 over 1,000. Giving us 0.01. Okay. Which is 4.691. Totally inappropriate to do this with a calculator. These are powers of 10. They're very easy to calculate with. And that gets us closer to the point of the exercise. Now we notice that this number consists mostly of this 4. The 0.6, the 0.09, and the 0.01, and it isn't 691, it's actually 4.70. I say it's easy to do these calculations of powers of 10, but I'm a little careless there. Okay, we get 4.70. That's kind of close to 4, but not that close. Well, if we do P of 100 over 100 cubed, and I'm not going to do this, but we do P of 100 over 100 cubed the same way we did this. Well, we're going to have a denominator of 100 here, 100 squared, which is 10,000 here, and 100 cubed, which is 1,000,000 here. So now these numbers are going to be further out from the 4 in the decimal expansion of the number, which makes the result a lot closer to 4. And if we follow this and do all the instructions, ideally we get some insight into y, p of x, which, well, into y, p of x over x cubed, let's say, approaches 3 as x approaches infinity. So that for log x, p of x gets close to x cubed, and that explains the long run behavior of p of x. That's where this assignment goes. You have a rule for long run behavior, and that's good. If you could apply the rule, that's and recognize that you need to apply it, that's definitely a good thing. It's a better thing if you understand why the rule works. And this process is good preparation for calculus. This is a pre-calculus class. So preparation for calculus, pre-calculus, prepare for calculus, which is why we have this exercise, which I've only given to students who appear to be doing pretty outstanding work in the course. Okay, well, that's it. And hopefully that answers some of the questions that I was getting from the individual student, but also provides a good illustration for everyone of the meaning behind this exercise. And I haven't gone through all the details. I haven't calculated this and shown what it does. I haven't calculated it for x equals 1,000. Okay, but I can easily do it and see how these results change. And then I can go into a more detailed explanation, or I would expect a student then, having seen this, to go into more detailed explanation of exactly what I mean by this. Don't want anybody to just repeat my words here. Want some explanation that reveals hopefully a high degree of understanding. I'll be happy with any degree of understanding, but a high degree of understanding, very beneficial for future work in mathematics, at least up through basic calculus.